Well, good evening, everybody. And thank you for coming out on such a beautiful sunny evening. It's really my proud privilege to welcome you all to this special event. And it's part of a series that is marking the centenary of the University of Leicester. For those of you that don't know me, I'm Professor Sarah Davis, Pro-Vice Chancellor and Head of the College of Science and Engineering at the University of Leicester. And also for those of you that are new to this series, welcome to Brookfield. It's recently opened and it's the refurbished home of the University of Leicester School of Business. So I thought I'd tell you a little bit about the venue because its history is inextricably linked with the history of the university. Brookfield's the former family home of Thomas Fielding Johnson, and he was the original benefactor of the university, and he donated the land where the university is now sited. And the original building of the university bears his name to this day. Fielding Johnson was a generous, successful and eminent entrepreneur, and through his work and his philanthropic activities, he brought together town and gown. And he hosted events such as this where we connect the university with the wider public. So we're very proud to be keeping alive that legacy today. So the series itself is called Difficult Conversations, and you might ask why it's called that. And really the purpose of the lecture series is to tackle controversial and potentially uncomfortable subject matters. And it's really demonstrating our commitment to being citizens of change and also of sharing our expertise and our impact with the local community and beyond. So we've covered topics such as hate crimes and nuclear weapons, to discovering more about the menopause and Mars. And all these subjects are broached in a candid way by subject matter experts. And the idea is to begin a series of conversations that can then lead to further discussion and further engagement and address the key issues of our time. The lecture series itself marks the centenary of the university. We were founded uniquely as a living war memorial. And Leicester is the only university in the UK to be established through public fundraising that was in memory of the sacrifices made in the First World War. And in the wake of that devastation, our founders turned to higher education to provide hope for the future. And that legacy of hope is really important today, just as it was then. And it makes this lecture series timely and important. So this evening, the panel will be discussing air pollution. 80% of us are living in areas where air quality exceeds safe limits, and so how can we address the air pollution crisis? As you'll hear from the panel, not only does air quality impact human health, it affects ecosystems, the challenges around climate change, and it impacts our national heritage. So the discussion is suitably titled, Every Breath We Take. My colleague, Professor Turi King, will introduce the panel and compare tonight's event. And Turi is a Professor of Public Engagement and Genetics at the university. She was part of one of the most ambitious archaeological projects ever attempted and was famed for her genetic work in the discovery and the identification of the remains of King Richard III in a car park in Leicester, as many of my international colleagues noted to me at the time. Seen on our screens as a co-presenter with Stacey Dooley in BBC Two's DNA Family Secrets, Turi is committed to bridging the gap between genetics and archaeology, and also to the public understanding of science and research. So thank you all, and I hope you have a really lively and informative discussion. And at this point, I'll hand over to you, Turi.
Thank you. So again, welcome everybody to this event. As you've heard, the evening's discussion is going to be around the subject of air quality. So air pollution is said to be a major cause of premature death and is the single largest environmental health risk in Europe. The World Health Organization estimates that 4.2 million people die prematurely every year from outdoor air pollution. It's such an important topic that there's even a Clean Air Day, and that was relatively recently on June the 16th. So we've got a crack team together on this subject. So we have got Anna Hansel. So Professor Anna Hansel is Director of the Center for Environmental Health and Sustainability here at the university. Her research has focused on environmental impacts on human health, focusing on long-term and lifetime effects of air pollution on respiratory disease from pregnancy to old age. She's also chair of the Committee on Medical Effects of Air Pollutants. Karen Exley. Dr. Karen Exley is the group leader of air quality and public health in the UK Health Security Agency, as well as being an honorary associate professor at the University of Leicester. She leads the UK Health Security Agency's strategic priority program on cleaner air. Joshua Vanderhei. So Dr. Josh Vanderhei is jointly part of the Earth Observation Science Group in the School of Physics and Astronomy and the Centre for Environmental Health and Sustainability. His expertise is in atmospheric science and translating that into applications in policy, industry, and health, and has projects that span working with Leicester City Council through to working on air quality and health in Africa. John Remedios. So Professor John Remedios is director of the National Centre for Health Observation, hosted here at the University of Leicester. He is a physicist, but his work integrates with chemistry, geography, biology, using satellite data for observing the Earth, examining climate and air pollution. He works closely with space agencies such as the UK Space Agency and the European Space Agency. And last but not least, we have got Professor Paul Monks, is Chief Scientific Advisor of the Department of Business, Energy and Industrial Strategy, as well as being a professor in atmospheric chemistry and Earth observation science here at the University of Leicester. Paul was the chair of the DEFRA Air Quality Expert Group for 10 years. So now you've kind of heard all their sort of accolades. I'm going to let them introduce themselves and about their research. So Anna, go ahead.
Thank you. You might have to stop me if I talk for too long. Thank you. So thank you very much. It's great to be here, and looking forward to discussing and having questions from the audience a bit later on as well. So I actually started my life in hospital medicine, so I was a respiratory doctor, and then I moved into public health, and from that into academic public health. And then for the last 20 years or so, I've been looking at health effects of air pollution and environmental noise and various other environmental exposures. But air pollution has formed a really big part of the work that I've done. And when I started in public health, I did my first PhD was looking at the Clean Air Act in 1956 and how that related to chronic bronchitis deaths over the next 50 years or so. And it was quite difficult to work with some of the data because I had to go into musty libraries and the basements and pull out some of the figures from 1950s and onwards. But you could see a relationship in terms of reductions in the chronic bronchitis deaths from the air pollution. And it was fascinating going back to the 1950s and then looking at the changes over time, because air pollution's actually got a lot better over time. And I think people often forget that air pollution has got better, but it's also changed over time. So it's changed from burning coal and fossil fuels to a range of sources. So we think a lot about traffic pollution, but how many of us know that agriculture is also affecting the air pollution in our cities, for example? So after I'd done this sort of work on the 1950s, I then started looking at very long-term effects of air pollution. So I worked with a colleague and we estimated air pollution exposures to black smoke and sulfur dioxide in the 1970s, 80s, 90s, and then particulates in the 2000s. And we were able to follow up some of the census data for around about 360,000 people and look at what they're exposed to in 1971 and then their risk of dying over the next nearly 40 years. And we could still see a signal in the analyses from what you're exposed to in 1971 to your risk of dying in 38 years later, which was quite, amazing. It's a small signal, but it's still there. But the good news from it was that if the air pollution had reduced, the air pollution you're exposed to in the last few years was more important than what you were exposed to a long time ago. So that sort of suggests that if we reduce the air pollution now, that's going to have that can outweigh some of the effects of the larger air pollution exposures we were exposed to in the past. So I've now moved out into a sort of wide range of research. So I have a PhD student who's looking at air pollution exposure before birth and in the early years of life, and how that's affecting cognitive development. And I've also worked with PhD students looking at lung function effects and looking at your early life exposures and how that affects lung function development. And looking really across the life course, and also now looking at different types of air pollution indoors. So I've got another PhD student who's looking at mould exposures, so that's an airborne, that's a biological air pollution, and looking at chemical exposures in the home and how that might affect people with asthma. So a big range of research going on now.
Karen.
Hello everyone, my name is Karen Exley and I'm part of the UK Health Security Agency, which is an agency of the Department of Health and Social Care. And the aim of this agency is about protecting public health from infectious disease, chemical, biological, radiological threats and environmental hazards. And I'm in a department which is around environmental hazards and emergencies, and I lead a team looking at air quality and the effects of air quality and air pollution on our health. And then we take that information, we learn from a lot of researchers, we do our own research as well, and we try and raise awareness of what that evidence is saying and improve understanding. So we work very closely with national government who have take action to improve air quality, but also local government. And so we're sort of bringing that together and sharing tools and resources, essentially. So yeah, I'm glad to be here. Thank you for inviting me.
Joshua.
Hi, everybody. Excuse me. Wow. I'm Josh Vanderhei. I'm jointly part of School of Physics and Astronomy, Earth Observation Area, as we said. And because I'm an interdisciplinary person, I'm also part of the Center for Environmental Health and Sustainability. And I guess my work is largely, I would describe it as air quality, policy-related air quality research, but sort of supported by work on technology development in sensing and understanding the air that we breathe, and the impact of interventions that we can introduce to improve it. I think, my work stretches from satellite observations to point measurements in the city of Leicester. One of the really exciting parts of my research is to be able to work with collaborators at Leicester City Council to really understand how policy and behaviors that behavior changes that we put into place in Leicester can really benefit our health. So really pleased to be here tonight. Thanks.
John.
Hi, so pleased to be here as well. Well, it's sunny outside, so it's it's a bit, and but it is my daughter's 18th birthday party tonight at our house, so I'm really pleased to be here. It's really good. Thank you very much.
She's pleased to have you here, John.
Yeah. Sadly, I have to go home after. But actually, a day like today is really good for the sort of research that I've been involved in, which is using the satellites, so instruments in space to try and look at air quality across the country, but actually across the globe. And on sunny days, we are very optimistic because we know we're going to get very good viewing on those days, giving us just the sort of information we want about air quality. And why might we want that? Well, if you were to go on the web and find all the measurements that are done in the UK, of which there are quite a lot, and there are all sorts of different groups doing them, but there are some networks as well. Spatial information is really hard. So it's fine to say a city is doing this, but you want to know what's happening, in your neighbourhood, in a particular part of the city. You probably want to know it on your street. And we can't do that from satellite. We can now break the bounds of cities. And that's down to a lot of work that we did, maybe 15, 20 years ago. So Paul and I collaborated a lot, wrote papers on how you could use satellite information to actually begin to understand and relate it to air quality, particularly in urban environments, but not just in urban environments. So actually in the UK, which is not that big a place, air quality matters wherever you are. And one of the reasons for that is that pollutants move as well. So there are many reasons, in fact. So you mentioned agricultural emissions, but actually pollutants move. So we kind of need to understand both where pollution is coming from and going to, and what's produced locally. There's been a huge change in what satellites can do over the years. Most of our satellites, again, work on using sunlight, in fact. So on a sunny day, we look at the sunlight being reflected back from the surface, and we make measurements that way. But there's actually systems that use lasers. So there's actually a very small but finite chance that as you're walking down the road, a laser beam will bounce off your head and go back out to space and be measured. It's not very high. So we got really interested in this idea of spatial distributions, but we like to look not just the UK, so we look at air quality everywhere. And of course, during the COVID lockdown period, we were able to see that change, and you probably saw lots of pictures on the TV. That came from our colleagues. We're one of the world-leading groups, working with groups across the world, trying to use these satellite data. And so we did our own research, and maybe later on we'll tell you a bit about that.
Paul.
Okay, thanks very much. So as I said, I'm Paul Monks. I'm a professor here at the university, and I work for government. I'll get to that bit later. So my life career has been, where does it come from, air pollution? Where does it go? And how does it change? I've had a kind of wide, three very simple questions, you might think. But actually, it's taken me about 20 years to even understand a fraction of that. I started off doing it in the laboratory, simulating the atmosphere in the laboratory. I went to NASA, and I looked at air pollution on Jupiter, Neptune, and Titan. If you remember Voyager data, that. And then I wanted to leave the lab because actually it was really interesting simulating it in the laboratory, but you want to go into the real atmosphere. So I started a career which has been wonderful and varied because it allowed me to travel around the world. And I've gone to measure air pollution in the cleanest air in the world. Now, does anybody want to guess? Because I'm an educator, honestly, so I'm talking to people. After a while, I get a bit bored. So does anybody want to guess where the cleanest air in the world is? Where could I have gone to look at the cleanest air in the world? And you're not allowed to answer because you know where I've been. Oh, you're spot on. So I worked at a place called Cape Grim, which actually is better than it sounds. And it's on the northwest tip of Tasmania, 40 south in the roaring 40s. And the wind there has not touched land since it saw South America 5 weeks ago. So it is the cleanest air in the world. And you might say, well, why, if you're interested in air pollution, do you want to go to the cleanest place in the world? Because if you don't understand what happens in clean air, how can you understand what happens in dirty air? So my career has been progressively, and it wasn't by design, it was actually, like most science, serendipity. It's traveling around the world, and I was very lucky. I looked at the cleanest air in the world, and then we went to look at rainforests, which produce huge amounts of biogenics. We flew around on aircraft. We flew at 250 feet above the forest, measuring the chemicals coming out of the trees. That's natural air pollution. Who can remember a song by Laurel and Hardy? Right? Which mentions air pollution. Come on, songs by Laurel and Hardy that mention air pollution. Yes, correct. Yes. On the trail of the lonesome pine. In the Blue Ridge Mountains of Virginia, on the trail of the lonesome pine. The Blue Ridge Mountains, why are they blue? They have natural air pollution. The trees give off chemicals, and they react with the atmosphere. And that's the Smoky Mountains, Bay of Smokes, and the Blue Ridge Mountains of Virginia, a la Laurel and Hardy. So that's that. Understanding that, we've gone from the clean air to the now naturally dirty air, and I ended up in places like London, Beijing, and Beijing was the most amazing place I've ever worked because, on one day you could see the mountains, and the next day I couldn't see the lady in red at the back. I mean, that's how bad the air pollution is. You could taste it in your mouth. That's it. So that's my journey as an atmospheric scientist, and I now, latterly for all my sins, I now work in government, taking science and supporting government, whichever one it is today, configuration it is. I haven't looked at my phone in the last 5 minutes to know who our ministers are this minute. To support that using of science to develop the next generation of air quality policies, the policies that help us deliver and control air pollution. And we'll get to that a little bit later, I suspect. But, well, okay, it's also good. How do you control air pollution? So that's a kind of a précis. So the take-home lesson for my career, where does it come from? How does it change? Where does it go? That's if you understand anything about atmospheric chemistry, that's the three things you've got to understand. Where does it come from? How does it change and move? John will let it move, and where does it go? And that's the whole air pollution story. What it is, we'll get to, I think, a bit later.
Well, okay, so you've been talking about you've been to sample really clean air. So let's actually kind of start at the beginning. What do you mean by air quality? You're going to do air quality 101, aren't you?
Air quality 101. So back to where does it come from? How does it change? Where does it go? So what comes from? So what is an air pollutant? So an air pollutant is something that's either a chemical, it's physical, or it's biological. And what it does is it changes the natural properties of the atmosphere. So we often talk about air pollutant gases. We talk of ones like nitrogen dioxide. Now there's a word already, nitrogen dioxide. That's the air pollution that comes out of the back of cars, particularly diesel cars, when you burn fuel. So any place you burn fuel, you get that. So nitrogen dioxide, carbon monoxide also comes mostly from fossil fuel combustion. There are also trace species, as we call them, trace species. Why do we call them trace species? Because there aren't very much of them. And actually, the amazing thing about these is they're in fractions of concentrations, very small amounts in the atmosphere, but they have big effects. And we know that, because actually one of the biggest air pollutants is actually carbon dioxide, and that leads to the greenhouse effect. You could actually say that climate change is an air pollution problem. It's just a very, very, very long-lived air pollutant in some senses. And we don't tend to talk about it like that because it lasts for so long. An air pollutant tends to get washed out. So we have things like ozone, so NO2 and carbon dioxide. Ozone is, you think, ozone, well, I've heard of ozone. Isn't that good for us? Doesn't it protect us in the stratosphere? Well, it's like many things, too much of a good thing. High up in the atmosphere, it's great. It's the Earth's sunscreen. Low down in the atmosphere, it aggravates the lungs and it's not very good for you. So it's actually formed by the chemistry that goes on in the atmosphere. It takes the pollutants that are emitted, you can cook them up on a nice day like this, and you can see it. And actually, often if you look on the Leicester horizon on a polluted day, you'll see a brown colour. That's NO2. That's nitrogen dioxide. And if you look, maybe see it today actually as the sun sets. So they're the chemicals. Then you've got physical, as I said. They're particles. They're literally small particles. The smaller they are, the actually, in terms of health, and we'll get to a bit later. I was about to say the more deadlier they are, but it's a bit it's a slightly public understanding. I wouldn't like to think the more deadly they are, but I'll let Anna get to that a little bit later. But they're the size, the fraction of your hair. That's how small they are. They're 0.1 the size of your hair. So they're really, really small. And the smaller they are, the further they can go down into your lungs and therefore get into your system. And they're made by every time you break your car, but they're also soil and dust in the atmosphere. They're also made by the chemistry again in the atmosphere. They can form what we call particulate matter that is a particle. There are also biological. I'm not going to ponder on those. You get spores and fungi. They are also, we don't tend to think of them very strongly as air pollutants, but actually what we're beginning to know is that actually the way that they interact around allergies can actually change the way that people respond to air pollution. I'm looking to my left because there's two people who've spent a lot more time researching that topic than I have. So air pollution 101, they're the air pollutants. They're emitted from a range of sources. Natural sources, we've talked about the Blue Ridge Mountains of Virginia, trees and the like, and what we used to call them man-made sources, but I mean, I think that's a very gendered term, isn't it? The posh term is anthropogenic, so but that's not much more help, really, is it, than that? But the human-made sources, in a sense. And they often come from, as I said, fossil fuel burning, friction of cars, and a range of other sources as well. So air pollution is created, it's transported by the wind, so we have to think about that, as John said, that spatial distribution, how it gets transported around. As you go away from a road where you're emitting, the air pollution falls off quite quickly as you go away from a road. The way that it's mixed, and the wind blows air pollution. Air pollution can be transported from one continent to the next. Some of it lasts that long. we call that intercontinental transport. Everything's got a nice name in science, intercontinental transport. So there is that. And then we think about the mechanisms where it can be lost. How is it removed from the atmosphere? Well, literally, it can be reacted away, chemically transformed. It can actually physically deposit out the system. The air pollution can physically stick to things, and we call that deposition. It can be rained out as part of that. And that leads us to the very important concept in air pollution of lifetime. How long is a pollutant in the atmosphere? How long is it before it's removed? And that is a combination of how much is going in, how fast it's removed, and how far it's transported. So the example I used to give students is methane. If one of you was to break wind today, right, and I'm not going to say that happens, yeah, but if one of you were to do this, how long do you think that would be in the atmosphere? If one of you was to break wind, how long is that going to be with us? Anybody like to have a guess?
2 hours.
2 hours. I've got
2 hours.
I've got 2 hours on the right. Anybody want to raise me 2 hours?
I'd say about 5.
5 hours. 5 hours. Now you're more like it. 7 to 10 years. No. So, gentlemen, and it's obviously only gentlemen here, it's only gentlemen, you want to think about this because it's going to be with us for a long, long time. It's going to be with us for a long, long time. And that's the concept of atmospheric lifetime, because actually methane, which is a very, very interesting molecule, which is also a greenhouse gas molecule, but actually it's on that lifetime verge where actually it could be an air pollutant for various reasons. I won't go into the chemistry of it, but can be with us for a long time. So that concept of how long something is with us in the atmosphere is an important concept. So, next time you think about it, 7 years. That's the destiny, 7 years. Sorry, I've held forth enough.
You all know about air quality now, right? What it is, okay.
Now we know what the take-home message
That is. So, John and Josh, how do we detect it? How do we measure air quality?
Should I
Yeah,
start
go on.
about on
Yeah.
the surface what we do, and then you
Yeah,
can tell us
yeah,
what we do
yeah.
from space. So, on the surface, we tend to use what we call in-situ measurements.
Yeah,
So
no using posh words.
It's not posh.
It's a posh word.
Okay.
In
I would-
situ, it's
Down your
Latin.
street, there's a
Okay.
box. In the box, there's some of this stuff.
We measure at a point, like,
Yeah, well done.
or in a small volume, and we use a number of different techniques. Where in the UK, a lot of the measurement systems that we have in place come from, the legislation like the Clean Air Act, which led to our requirement for the civic authorities to monitor our air and make sure it meets certain standards. Now, in a city like Leicester, we have about 5, 6, something like this, what we call regulatory monitoring stations. So there we get, they're calibrated regularly, they're supposed to be traceable, and that tells you, with high level of confidence, what the key pollutants are, that the levels of the key pollutants are that we monitor. So the particulate matter, the NO2, the ozone, the carbon monoxide are the primary ones that we're looking at. Now, if we wanted to have an understanding of air pollution in Leicester, where might we want to put our stations? Any ideas? City Centre. Okay. Oxford Road.
Highfield and Belgrade Centre, and that way, yeah.
Main roads. So
Very good.
yes, absolutely, absolutely. Now, so some of the stations we have are right at the side of busy roads. Some of them are representative of the air in the city centre. And one of the points I'd like you to think about is the fact that especially something like nitrogen dioxide varies a lot over the city. So if you're measuring right by the center of the road, right by the side of the road, you'll get a lot. If you step back a bit, you won't get quite as much. If we want a picture of what that pollutant looks like over the city, we have to measure at a range of those points. So some we call roadside, some we call urban background, and then we also like to look at sites called rural background. So from these different points, we get some of the information. These are what we use to regulate currently, but there are a lot of gaps in between. In addition to these regulatory monitors, one of the things that has emerged over the past decade, maybe we should say, lower cost sensors that you can put up in larger numbers. So you can put them in dense networks. We have a study looking at one of these where we have about 8, 9 sensors in an area of 2 by 2 kilometers. And you can also carry them around. So you can now measure what you're exposed to, let's say as you go to work and back. And recently we did a study with the City Council where we did just that. We looked at the morning commute from the starting point where some of the council staff lived and went into the office. And we did some walking against driving, and we did some cycling against driving, starting at the same point, ending at the same point, and following the natural route. And one of the interesting things from these in-situ measurements was we found that inside the vehicles, even inside an electric vehicle, the level of NO2 exposure that you have can be higher than it is right along the side of the road, because you can be taking in the exhaust of the car right in front of you. So I guess we have the regulatory network. That is what the government looks at to see, are we meeting our standards? Those can only sample so many points. We can add more sensors to get more points, but there may be the data we don't have quite the level of trust in, or the accuracy is like larger amounts of error. Maybe we'll have time to come back to this, maybe we won't. But there's another really important tool at the surface, which is using different kinds of models to predict what the exposures are in the points in between. So I will hand over to John.
Can I just say one thing about this phrase, the urban background and regulatory. What we're trying to get from a regulatory monitor is what is the exposure of somebody. So, not many people stand by the road all day, yeah? So the question is, how can we get a measure of what they're exposed to? So we use the idea of the urban background as the background level, the blanket over the city, if you want to think of it, so we can work out, are people receiving too much air pollution? And that's the concept of measuring. And regulatory measures are to do that. And I'll give you one of my other facts. What is the average height of a person in the United Kingdom? In meters only. In meters only. I can only do it in meters.
Oh, we're not in Europe.
No, the average height of the population in the UK. Nearly 1.2 meters, and that's the height that we sample at, and it's the height of your mouth. The average height of the mouth, and that's what we use those sensors for, because of course we're interested in how much you're breathing in, and that's the background. Sorry, Josh, that's got to bring the context to it. So actually, there are some. So statutory measurements are really for adults, and there's a really interesting. I mean, Anna's done some work on this as well. There's a really interesting question about children, their exposure, where the height is markedly different, and also especially children in prams as well. So I shall leave. There are some more experts on that on my left, so I shall leave that to them.
So John, tell us quickly about satellites.
And since it's called Difficult Conversation, I'll introduce a sort of slightly alternative note. So satellites in a second, but just picking up from what Paul said and what Josh said. So one of the things you can see is that, okay, we can put sensors where we can, and we've already mentioned, I think, quite a lot of important places. And you want those. You want to measure a lot of places, and you want to measure all the time, which would be great if we could do that, and we're trying to do that, but we can't, in fact, do it at the moment. So there's one really important thing that happens, which is we use this model, or a set of models, in fact, different models, and then scientists disagree about what all the models do and which one's better. My one's better than yours, guaranteed, all right?
So you should explain what a model is, because it's not Kim
Basinger,
it's not...
Would you do a 101?
I'll do a 101. So what models are a numerical representation of the atmosphere. So we put them in a computer, and it allows us to see how the air pollution evolves apart. And why that's important, as John says, is we can't measure everywhere all the time. So it's not something you find in GQ or other magazines are available. It is a method for being able to produce maps often of air pollution that we can then again use to work out more accurately the exposure of people to air pollution.
Yeah. And so satellites come in there. And for me, an important driver about this is actually, I think regulation is important, absolutely, because that's what people try to conform to. But as a person, I just want to know what it is. I don't know if you have that feeling. I just want some feeling for, do I live in a bad air quality place or a good air quality place? And yes or no, you know. And I might choose to, and we might come back to this. I might choose where I live, for example, based on it. So what the satellites can do there is try to build up a better picture of longer term change in a consistent way of how our country or our area compares to other countries or other areas. If you think about these computer models that are then doing all these calculations, when they produce an answer, is that answer good or is it not so good? Does it work all the time? So I mentioned the sunny day. So satellites particularly use the light from the sun. And what we're used to, of course, is sitting in the bottom, so we get the sunlight falling on our heads. But actually, where satellites up in space, it's looking what comes back out. So actually, a lot of solar radiation, a lot of sunlight, doesn't stay here. It gets reflected or scattered back out of space. And the pollutants actually reduce, well, mostly, there's a bit of complication about that, leave that the complications. But mostly it reduces what we see out of space. And so if we have a clever enough instrument out there in space and we choose the right wavelengths, those of you who are scientific, we use what's called a spectrometer mostly, you can actually distinguish different pollutants. So you can measure the concentrations of different pollutants. And Paul mentioned a whole range of those things. So we say the brilliant thing is you can try and do it over your country compared to a different country over time. Brilliant example was lockdown. So we actually did a bit of work with the in-situ sensors, sensors in one place, and the satellite sensors during lockdown to try and understand how big an impact that made. So you can get some figures on reductions that come from, for example, in nitrogen dioxide, 20% to 50%, depending exactly where you're looking across this country. And similarly, you know, huge effects actually, you know, in China or India or Italy, and you could really see the change as you made those measurements. Now, this is where the models come in actually, because if you just took the data naively and you said, here's the data before lockdown, here's the data after lockdown, you go, okay, so that's the improvement we made. It turns out not to be quite simple, because if you take the first part of lockdown, particularly in China, but also in Italy, that was kind of in the springtime. And at that sort of time, a pollutant like nitrogen dioxide is actually decreasing anyway, because the sunlight actually sets up a whole chemistry that destroys it. So you have to remove the natural chemistry effect and work out the difference we made. Nonetheless, you know, if you look in China or in Italy, you see really big impacts. So we've learned something about the scaling. If we do a big thing, how much do we improve the air quality? And that's how the satellites help. One of the big things we'd like to do, so that's a gas. The big thing we'd like to do is add particles to that. So we'll maybe come back to particles when we have some more from our experts. But essentially, there are satellites, and there's a whole fleet of satellites above your head, whizzing around trying to get this information. And one of the biggest ways they make an impact is by feeding these computer models and improving their calculations of what's happening in your local area.
So we've been listening to how, you know, what it is, how we measure it, and the reason why we're bothered is because of the health implications. So Karen and Anna, do you want to talk us through those?
I might start on the lockdown, because that's really interesting about the air pollution, because you know, there's lots of interesting things that came out of it, but John was talking a lot about the NO2, I think, in particular. And in the UK, our strictest lockdown in 2020, we did a study where we looked at what was actually being measured on our national network monitor, and we found that the reduction in traffic on average was about 70%, and the NO2 levels came down 40%, but the PM2.5, the particulate levels, were not much lower than normal. You know, they were about 10%, and that's partly driven by the weather. So it is quite complicated when you look at it. And from a health perspective, you're sort of thinking, well, this might be a really good opportunity to look at what happens to health if we have these changes to air pollution. But it's very difficult to study because there were all sorts of other things going on during the pandemic. So, people weren't going to the doctor or the hospital as much. And then there was this, huge amount of respiratory illness that we don't normally have. So it's been very difficult to use that as an experiment to study. And the other thing we found quite difficult to estimate is whether air pollution affects your COVID risk. And there's a lot of work going on around the world on that. It's likely to be a factor, but it's probably not a very big factor, is the research so far. But there'll be ongoing work on that we're doing. I think in terms of the health effects, I'll pick up on the model, because for health effects, we spend a lot of time looking at as many people as we possibly can. So I have some studies where I'm looking at millions of people, or some of them where I'm looking at thousands of people. And ideally, we get everybody to carry an air pollution monitor around. They'll be sort of hooked up like this for weeks at a time, which it's just not practical. So we end up relying on a model to tell us what people's air pollution exposure is. And there are tens of thousands of studies now looking mainly at outdoor air pollution. We haven't talked a lot about indoor, maybe we can come back to that. But outdoor air pollution, showing that air pollution has impacts on all of the body. So it's the larger particles are impacting the sort of upper airways, and the smaller they are, the further they get down into the lungs and then into the bloodstream. And then we have impacts from these gaseous pollutants, the NO2, the ozone, and they have sort of damaging effects on the lung. And we can see we have impacts on heart disease and on lung disease, but we're now finding impacts on diabetes, on dementia, and things like birth weight. So it's affecting babies. I think the other side of that is to think about how large are these effects, and mostly, well, certainly across a whole population, they're relatively small. And they're not the only factor that affects health. I mean, that's the other thing to keep in mind. So, there's lots of things that can be done to offset the impacts of air pollution, like not smoking, having a diet that has a lot of fruit and vegetables. So that's got vitamins that can offset some of the adverse effects of the air pollution. Exercise, very good. Just sort of for general health. There's various other factors about trying to live a healthy lifestyle that can offset impacts of pollution, but obviously pollution, if we're able to reduce the exposure or not to be exposed to it at all, that's good. I mean, from the health effects we can see there isn't really a threshold. It's not like we get to a certain level and then there's no effect below it. We can see actually effects right down to very low levels of air pollution. So the lower the exposure that you can have, the better.
Karen.
Yeah, so we've done some analysis that suggests there's about 29 to 43,000 deaths, equivalent deaths from air pollution every year in the UK. So we're talking about a really significant public health problem. And you may think it's just about breathing, people with asthma. Now, while that's really important and serious, you may be aware of that young girl, Ella Kissy Deborah, who died. It's now on her death certificate that she died from asthma and air pollution. But we have other things, so it's affecting our heart and our lungs. It's affecting all sorts of systems in our body. But we've talked a lot just about outdoor air pollution. We've also got indoor air pollution as well. And that, we know less about it. It's much harder to go and measure air pollution in everyone's home. So we don't do the studies in the same way, but we do know it similarly affects our health from respiratory and heart and cardiovascular diseases, etc., but also allergies. And then you've got things such as carbon monoxide, so people who have boilers in their homes, solid fuel, that sort of thing. If they're not well maintained, then you may get carbon monoxide poisoning, and that affects how oxygen goes around your body. But then we also have things called volatile organic compounds, and they come out of all sorts of things, the products that we use, the way we do our cleaning, our carpets when they're new, even paints, they have these smelly chemicals that come out. And so we're trying to learn more and more about how they affect our health, and we'll talk a bit about how you can avoid exposure to those a bit later.
Actually,
Just
right
on that
now.
last point, if I can come in, I think the very interesting thing about the indoor-outdoor contrast is that, actually, as Anna said at the beginning, air pollution today is 75% better than it was 15, 20 years ago. But actually, as that comes down, the exposure pattern is changing, and we're getting more of a feeling that now people's indoor exposure is sort of going up in some senses. So actually, our understanding of the indoor environment, which is less, is becoming more important as the outdoor environment becomes essentially cleaner. We can debate about whether it's clean enough, if you wish, but that's a very interesting contrast that's taking place now in our science. And its indoor environment is massively complicated. If the outdoor is hard, the indoor is really hard because it's so different everywhere.
Everywhere, everybody's house is different. And if you went to a university as well, and that'd be completely different.
Ventilation rates, sources of compounds, yeah.
And I think that's the tricky bit about understanding the health effects, is everyone's different. Your exposure might be different, your behaviours, how you do things at home or where you go are all going to be different. And that talking about children as well, thinking about how they've got developing lungs, so they're more at risk from air pollution. And if they're on a busy road, they may be actually closer to the source of the exhaust coming out of a car than an adult would be. So, there's lots of things to think about when we're looking at how it affects our health.
So Anna, you've mentioned a little bit already. What are the things that individuals can do? What are the solutions at an individual level? Not solutions, but things that people can do to help. And at the government policy level as well. What do you guys think?
I'm going to go first to this Every Breath We Take, because there was a fantastic report published by the Royal College of Physicians in 2016, which, if you're interested in this area, have a look at. It's still very relevant. So they looked at all the health evidence. It's got a very, easy to read format. But they also took some time at the end to think about what you could do as an individual. And I think, one of the issues is sort of keeping informed about the issues. And the second is don't pollute. Don't try not to be a polluter. And it's not just, the individuals, it's also thinking about that at the society level. And be aware what's going on in your local area, your local government and national government, and don't be afraid to get in contact with your politicians to talk to them about your concerns about air pollution. I think that's really important. We're going to get action from it if our local and national politics realise that this is something we're concerned about.
And government policy level. So Karen and Paul, this is your sort of area.
The thing is, it's going back to that one. And the thing is, the government, they make all these promises, but they never actually follow through with them. That one. So that's the trouble with the government.
Fighting. So I'm going to disagree with you. I'm going to disagree with you because I will still go back to that we have had a massive reduction. Now, so the question that we often get to, the way I often frame this question is how many deaths are acceptable. Now, that's a very strange way of putting it. So air pollution is coming down. What we're finding scientifically, as Anna absolutely said, is the threshold for its effect. There isn't one. We used to think there was a safe level of air pollution. Strictly speaking, there isn't. So we are now bringing it down. We have had a great deal of success. Governments across Europe have, it's far, far cleaner than it was, in the peace supers of the 1950s. So actually, legislation has had effect. The question is, how good is good enough? How far do we have to go down? And actually now we've got policies that say, for example, for PM 2.5, the higher it is, the faster you have to bring it down. So there are policies that are trying to do that. But actually, the last bit, removing the last bit, it's not really the last bit. These low levels actually is very expensive, and actually takes real concerted action. And one of the things that's really going to change is also as we move to decarbonise our society, as we move to net zero and affect the climate change. Actually we're going to change. We won't be able to buy a petrol car after 2030. You won't be able to buy a hybrid after 2035. That's markedly going to change the air pollution patterns, that we see in the future. So there are policy, and I, if you want, I could talk a little bit about the intersection of policy and climate change a bit later, because I think that's a really interesting area. But I don't know if you want to pick up on has the government done enough, Karen? I am throwing that ball. I'm throwing that ball left.
You were just relieved, weren't you?
So I'm not directly government, but we do work for the Department of Health and Social Care, and I think that's part of our role, is to really say, look, this is the evidence, this is the seriousness of this problem. Take that evidence and put it into action and try and support them with that. I know local authorities are often wondering what are the best, most effective things we can put in place that will really make a difference to emissions, but also our health. And that's not easy, definitely not, is it? But one thing I just wanted to pick up that you were saying, Paul, about the change in our air pollution. Now we're stopping or having these diesel cars and cutting back that way. That used to be, transport is a big part of the air pollution. But now we're getting worried about things like solid fuel burning, so wood and coal burners. They're producing about 17% of our emissions of particulate matter in the UK. So there are things that we can do by using ready-to-burn wood, or perhaps not using them, or using eco stoves. But there's lots of different pollutants that we need to think about, and the sources and how we act on them.
What about the Environment Bill?
I can.
know you were going to.
I mean, no. The Environment Bill. So how many people in this room know that there's an Environment Bill that went through Parliament, and there was a consultation?
Oh, okay.
So there's been a consultation on the limits that have been proposed for that. So I know about it because we've been talking about it in the committee on the medical effects of air pollution. So I can't, speak for the committee, because the committee's committee and their views should be published in the next few weeks. So we've done a statement on it, but I can certainly comment as an individual. And it's really quite interesting because they've proposed, the DEFRA proposed a limit for particulates, for the fine particulates, PM2.5, the ones that get right deep into the lungs and potentially into the body, that is 10 micrograms per metre cube for an annual average. And if you look at that on first sight, it's the same as the World Health Organization put forward in 2005. And the government say that we'll get to it by 2040. And also the WHO, World Health Organization, published some new guidelines last year where they lowered the limit from 10 to 5. So, at first sight, you're sort of thinking, well, this isn't looking too good, really, is it? But actually, if you look at the detail's really important on this, because the 10 micrograms per metre cubed is a limit everywhere. So it's by the busy roadsides as well as where the people live, as well as like the Highlands of Scotland, which you've got almost no air pollution, who could meet the new WHO guidelines now. So that's quite important to realise about it. And the other thing is, in the fine print, there's a reduction target. So there's a continuous reduction target, as well as this annual limit. And that's really important because otherwise you just see, the reductions where you can, and you wouldn't get reductions in the higher areas, or you might get areas that are quite deprived, that have higher air pollution levels already, just not moving down as fast as the more affluent areas that can put measures into place. So that's also really important in terms of population exposure. So we know that reducing exposure saves lives. So the more you can reduce exposure, and if you can keep doing that across the whole population, that's really important. And as Paul picked up on, getting down to those lower levels is actually really hard. And it's also quite hard to measure at those low levels because you get to the limits of detection on some of the machines. So it's actually quite complicated looking at that. The other thing that is interesting about this consultation is they did some cost-benefit analyses, and by reducing air pollution, you have benefits on reducing carbon as well. So, there's a sort of win-win situation of improving the climate, improves your air pollution, as well as, tries to help with climate change.
The other bit to kind of think about this is, what do I actually have control of? What do I actually have control of? So, 40% of the pollution probably in Leicester today was generated over France, Belgium, and the Netherlands. I don't know which the wind direction is today, but typically that's the case. Why? Air pollution doesn't respect borders. It doesn't have a passport, a blue one or a red one. It will travel distances. So actually, that's why when we talk about air pollution control, we have to work together. So actually, luckily, even though we've left the European Union, there's something called the UNECE, which is the area. So we're all trying to reduce. Because actually, if you don't reduce as rapidly as your neighbours, you can end up with some very interesting sort of still importing pollution. Because it's actually, we call it, as I used the phrase earlier, we call it a transboundary problem. That we export our pollution. The classic example, actually, of which was, if you remember, the acid deposition, the acid rain. So our coal-burning power stations in the UK, where we were transporting our air pollution to Sweden. And it was coming out as then acid rain and killing the Swedish trees and the Swedish fish. And that's just that's an example that air pollution doesn't respect borders on this. It's a regional problem. If we're in Leicester today, we'll have produced, I would guess, something like 30 or 40% of pollution in the city, and about 60% of it will have come in from outside. And that's why you've got to take concerted action at, both at the local level, but at the national and also the international level. It's all those sort of levels.
And maybe just to come in there, I mean, for me, it was interesting looking at the satellite data that we got during the lockdown, and we were, of course, looking at the improvements. But what you could actually interestingly see was both the impacts of the transport between us and neighbouring countries, so that was really clear, actually, in the data we were looking at. And particularly as one country started to lock down, and you could still see the residual pollutions. But actually, interesting enough, if you look at our own country, there are almost corridors, and they do change because it's wind dependent. So, but there are corridors or areas, if you like, where you can see that regions are exchanging almost. So across the Liverpool, Manchester, Sheffield areas, you see something, across London and the southeast. So there's definitely this connected within the country part. But I still feel that myself having sort of observed the data as well and listened to the health arguments, there's a lot you can do by talking to your local authority, by looking at how items are planned. It's quite complicated how we plan things. We need to move at some level, don't we? We need to have transport. So a great move is to change the type of transport that we have. And that's been quite successful. But the really important thing, I think, is to keep it on the agenda. So what people are very good at is that there's and that we ourselves are, as voters, we're very good, aren't we? That there's a problem, and for a year or a year and a half, we're really on top of it, and it's a really important issue. And then gradually our attention floats to something else. And really what you're talking about is the quality of the environment in which you live. So there's a part of a much bigger question here. And that's as much about, as Paul said, there's no actual threshold. It's much about us deciding what does our local environment want to look like? What does it want to feel like? When I go out the door, do I choose to go in my car? Do I choose to cycle? But what route do I take as well? And what do I think? Can I achieve a consensus with the other people who live in my community about how I want to live? And I think that's really important. And local authorities do have a lot of powers around that. And you see that in planning applications. They have to answer questions around pollution, etc. One of the local companies that spun out of the university, I don't know how good that data is, but actually you can get estate agent reports, which are environmental reports about the place where you live. And that includes some sort of estimate of the air quality in your region. So you can actually vote with your feet in a way. I don't suggest you do it too far, but you can think about, and you can say it's part of what I need to know. So
I think there's one more thing I'd add, actually, that actually air pollution is very socially inequitous. You probably don't think about this, but if you think about most UK cities, where are the richest suburbs of those UK cities? So, in Leicester, is it? They're upwind, absolutely. So air pollution has designed the UK cityscape. So UK cities that grew in the Victorian era, which was when industry grew up, the prevailing wind direction in the UK is southwesterly. So actually, if you think about it, often the richer suburbs are to the southwest of the city, because they would live upwind, and the poorer suburbs are to the north of the city, which is often where you find industry, because the wind blew in that area. So actually, air pollution has styled our urban architecture in some senses, and the way that our urban cities have grown up. Edgbaston, Alderley Edge, in all those sort of big cities, any city that grew up, actually air pollution has styled that. And that also means, today, in an average city, that actually is often the socially disadvantaged that are disproportionately impacted by air pollution as well, because of that urban architecture that we have. So it is actually very social inequitous in the way that it affects people as well.
So I'm going to bring this bit to an end. You've got to listen to them. You now get to ask questions. You've got experts sitting in front of you. Any of you got any questions?
Sorry, I missed that. Who's
One
this?
of the back, chap in the blue.
Yeah, I wrote some things down. In some wealthy areas out in the countryside, they're having these wind farms. They're against these wind farms because they're considered as ugly. They're eye pollution.
Mm-hmm.
And the government has just given them money for that. Just offered them money to put those farms there because they're seeing eye pollution. Now, if you live in the city, as you just been saying, if you live in the poorer areas where the pollution's worse, where you haven't got a passport to get out, where you were saying it's nothing to do with a passport. No, you haven't got a passport to get out there. So you have to put up with that pollution. Yeah, and you get nothing from the government. So I'm looking at more about the injustice of air quality. There's an injustice there, not much has been said about that. Why are they not offering people more money or reduce their rates because they're putting up with more pollution than in other areas? If you can do it for eye pollution, why can't you do it for air pollution?
That's a good question. So, I mean, who else? Who would like a go at this? Oh,
You, Paul.
yeah. Okay. So I think it's interesting the question of wind farms, and subsidies for onshore wind farms is an interesting one. Yeah, how do you deal with that? So as I said, it's social inequitous at the moment. I don't think, in my view, it's not a question of paying people for damage. It's about reducing air pollution in a way that means that people, wherever they live, are safe in terms of the air pollution that they breathe. So I think that's the goal of air pollution policy and the sort of research that we do to understand how you can control that air pollution and make it safe where anybody may live for that air pollution. So that's my push on that. That'd be my wish, if you will, around this. On planning for wind farms, that's a completely different topic, which I could bore for hours on. Onshore, offshore wind farms and current policy planning statements. Yeah. It's a different topic in the sense of. Yeah, unless anybody else.
Yeah, well, I was just going to say, I don't know if I can have a go. I think it's a really interesting question, but I think the problem is not so much could you throw money at it, but what would you put at it? I mean, it's what's going to make the difference for those people living. There's no point just having money for the people living. So, yeah, sure. But that's so that. But what you're doing is, yeah. But in some ways, I don't actually agree with the first. I don't think. So my problem is I don't agree with the first bit of necessarily giving them money to have the wind farm there in the first place. So my problem is if you give people money to live in places which are not so good for them, whatever the source of pollution is, I don't think for me that's not a good way to go. So that's what. No, I wouldn't say that. What I would do is I would concentrate. I'd concentrate on more effort on cleaning up the areas. So I'd prioritise cleaning up the areas which are suffering from it. Yeah. So no, that's what I would prioritise because I think the problem is if you give them money, then they're going to move. People are going to move there because it's cheaper for them to live there. And I think it's breaking that cycle.
Sorry, you and the teal there.
I'd just like to give a very good example. I'd like to give a local example of improvement of air quality, insofar as we had a local meeting at Clarendon Park and Victoria Park area, and it was suggested that in order to improve the city levels of pollution, they would actually divert the road into the city and send it along Victoria Park Road, so that, in fact, the pollution will be worse on the higher areas. I don't know if they expect the wind to sort of take it away miraculously, but the city centre will improve because there's less traffic going through. But it's just shifting the problem.
Displacement is a real problem. I mean, so often measures that just move it from one to the other. I mean, often the argument about building new roads is actually, if you make it, it's called suppressed demand. If you make it easier to travel, then actually more cars will travel as such. No, I think my hope on that is, as the one I said earlier, I think actually the pollution from cars is going down, partly because we're going to move to more and more electric vehicles. We could have a very interesting debate about air pollution in electric vehicles, if you wish, because yes, there's zero tailpipe emissions, but particulate-wise, there's a really interesting question about how much particulate you get from electric vehicles. But you know, we've got to go to we've got to go to decarbonised transport, whether it's electric or hydrogen or whatever, because of the climate challenges. But it doesn't solve absolutely the air pollution problem around that. But I think that's good. So I think we have to be careful of displacement. I think that's true. Anna talked about the concept of population mean weighted exposure. And so actually, often we look at measures that, and it's back to the social inequity issue, we look at measures that reduce air pollution for the most people. So actually maybe moving cars onto Victoria Park Road, where it's actually easier to get the pollution away, because it's more open. It's bad for the people who live on Victoria Park Road. I'm not going to sit there and deny that, but actually more people benefit from that. And that's the sort of analysis that you have to do in these sort of trade-offs. Josh has done quite a lot of work on this sort of stuff.
Yeah, so I guess I just want to say on that, the other, if you ask the City Council their first recommendation, it would be reduce the journeys, reduce the car journeys, right? And so, sometimes there are ways to introduce like changes in the road patterns to try to also help. And we're studying some of those along with the council to understand, okay, well, if we turn this into a pedestrianized road, what happens not just to the air quality on that road, but in the surrounding roads as well. And this is an area, actually, there's a need for more evidence. So it's really important, I think, that we're working on this. But the first line you will get is, do you, and I don't mean you individually, but do you have to drive? What's the alternative? But it's broadening out from this. I had a really productive conversation with a public health expert from the council, Leicester Council today, who was talking about behavior change in public health. And often we say, well, if you're not doing it, it's because you're lazy. You're just not motivated to change your habits. But in public health, in air quality, all these things that require behavior change, we need to create an environment where people have the capability to make the change, and they have the opportunity to make the change, and then also have the motivation to make the change, right? So if we have, if we make all our cars, get rid of all our roads for vehicles, then the opportunity and the capability are there to not use cars, right? That's a radical change. But I guess I would just say that along with these sort of changes we're looking at with traffic, roads, different things, we're trying to see the larger picture, but we're also always coming to this message: can we shift the way that we're behaving as a society?
I know you've been very keen to ask a question.
Hello there. I used to work and live in northwest Leicestershire, a coal mining area. I used to manage a mushroom farm. Pollution was something we noticed 3 or 4 days before it was ever announced on the television, because the mushrooms stopped growing. They just gave up. And on the pollution side of it, I had no troubles with the roof on my house until the coal mines closed. And what happened then, we had moss growing on the roof. And it would all fall down and go and block the gutters up. It was absolutely bloody wonderful. Sometimes I just wished we'd still had the coal mining. But, you know, even my motorcycle, I rigorously had to wash it every single day because of all the dust. As the coal mining died, northwest Leicestershire just became warehouses. And what you get with warehouses is lorries, 24/7. And I would say that pollution in northwest Leicestershire is higher now than it ever was when the coal mines were there, because there were bigger particles, they came through the air, they got washed down, but now we don't have that. I don't really see how we're going to change anything with this pollution, because...
So lorries, I think, is very interesting. So what's going to happen in the lorries is that they're moving either to biogas from anaerobic digestion, which is a different problem. Yeah, but I think that's one step because at least it's sustainable. The lorry manufacturers are looking at two candidate technologies. Surprisingly, for me at least, batteries, because actually, you know, but their battery performance now, Scania are building lorries that run off batteries. So, and then the other one is hydrogen, by the way, that will come, because actually, which is probably what you should use for heavy haulage. But I think you're right, and it's what I said earlier about vehicles is that we can reduce the tailpipe emissions, but you still at the end of the day, you've got the tyre in contact with the surface, you've got the brakes.
Which is something that's been going on for a very long time.
Very long time.
Very north of Scotland, there is still, they can find traces of rubber from tyres in little streams. Sorry, burns.
Microplastics, yeah.
It's just diabolical. This is the one side of pollution that we've never really looked at, is the pollution of rubber. Every tyre wears out, and it leaves something behind. And it's there forever. It's in the soil, it's in the ground, it's in what we eat, what we grow.
Well, you can still see lead from when we used to put lead in petrol in the soil. But, I mean, which is quite interesting. Yeah, so I think you're right. And actually that whole persistent pollutants and microplastics, as we call it, and the rubbers, I think has really gone up the agenda. And I think there will be... I mean, I don't know, Karen, if you're looking at that in your team in the sense of because it's kind of a new and emerging pollutant, really. I mean, maybe I'll just kind of pass over to you because you're probably nearer to the microplastic things than I am.
No,
Mm-hmm.
yeah, but it's interesting, isn't it, what we focus on? We would look at the biggest problems or the easiest things to deal with, and it's very difficult to measure and understand that. We work with our toxicology teams, so they're people who look at how chemicals affect our health, and they're doing lots of work to see how it might affect our health. And people are identifying microplastics in water and all sorts of places. So it's absolutely a new area that people are starting to focus on.
Suppress demand, it's a wonderful thing.
Sorry, yes, you... Sorry, yes, you...
I mentioned Oxford Street, I said street, because I work occasionally in that area. It's noticeable, one of the busiest, must be one of the busier roads in the city, is being gradually, the Leicester City Council planners seem to have decided the ideal thing to put on Oxford Street is lots of large buildings, tall buildings. Oxford Street I'm talking about, which is a very busy road, for those who don't know it, in the middle of Leicester. And at the moment, there seems to be a concerted effort to line it with 5- and 6-storey buildings, which in terms of air pollution seems to me to be a bad idea. So there's that interaction between the built environment. You've talked about how air pollution affects where people put buildings, but also where people put buildings must have a significant effect, certainly at a local level, on pollution. Have you got things to say about that?
And we've done at the university quite a few studies on that. What we did, we built a 3-dimensional model of Leicester. Then we put it in one of our supercomputers, and then we flowed the wind. Because we need to do a lot of calculations, and then essentially we flowed the wind across Leicester, We flowed the wind across Leicester, and we looked at the places where the wind got trapped. And actually, what we were interested in, which is another whole story, we were interested in the role that trees play. So trees can be used to I'm going to use the mitigate air pollution, but what they don't do is they either trap it or they move it. And actually, kind of what we found is if you want to reduce air pollution over the whole of Leicester, you plant more trees in the suburbs. Because actually, in inverted commas, making the city rougher, so as the air flows across it, if you like a piece of sandpaper, if you make the city rougher, and that is you place trees in the suburbs, that means the air turns over more and doesn't get trapped as much in those what we call urban canyons around that. So we have done those sort of studies. I don't know in the planning legislation, I don't know if you know in the planning legislation whether they have to do an air quality assessment now around those sort of streets. I'm not sure.
I don't think so.
I don't think you do.
Yeah.
Okay.
No,
I don't know.
Can I just come in, though, on the tree thing?
Yeah.
And also planning versus air quality is always thinking about what are the unintended consequences of something that you're doing. So having these taller buildings may mean that the pollution is being trapped. But trees, they can create their own type of pollution as well, and certain ones are known to be very allergenic for people, so you have to be really careful about which species of trees are planted. So again, it's not straightforward just planting any tree to help with that.
Right, I'm getting the nod from the back that we've got to wind this up, but you will be able to continue the conversation after this because there's sort of drinks and nibbles and things out there when we go. Oops, Sarah. Yeah.
Oh, well, thank you so much to our distinguished panel, to our fantastic chair, and to all of you for such a stimulating discussion and informed opinions and sharing those. And it is a real shame to bring it to a close because I could see a lot of hands, but I do hope the conversations continue outside and on social media. Just to note that the recording from today will be online and it'll be accessible in due course for those that aren't able to join us tonight. And I really do hope you're able to join us outside to continue the conversation over drinks and canapes. Do join us if you can. And thank you for coming along this evening. And if you would join me in a round of applause for our fantastic panel.